Let's discuss a question from thermodynamics. You have a reversible heat engine which delivers. So you have a reversible, let me draw it like this, reversible heat engine which takes in heat from a reservoir. Let this be Q1 and gives out rejects heat to a sink. You have to have a sink, okay, as per second law of thermodynamics, and it gives some work. So it resets at 27 degrees, which is nothing but 300 Kelvin. Remember, when you are dealing in heat engines, always you have to have a Kelvin, okay, as the temperature. So the work that is delivered is everything is in rate here, rate units. So I mean per second. So 0.65 kilowatt is the work done, whereas heat rejected is 0.4 kilojoules per second. So Q1 is something which is absorbed by the heat engine. I mean, this is taking from a higher reservoir. Okay, and so what we want is how much is this heat, that is how much is the temperature. Actually, temperature of the source is something which is asked. We don't know Q1. So I think what we can do is, remember that when you have a reversible engine, the ratio of the heat absorbed to the heat rejected by the heat engine is same as the ratio of the temperature source and the temp of the sink. So this is valid only for a reversible engine. Q1 by Q2 is equal to T1 by T2, but we don't know Q1. So from this, what we can do is Q1, I mean from the first law, from just the energy balance for the heat engine, Q1 is the heat taken, W in a cyclic things. Remember that in a cyclic device, the change in the sum of the heat absorbed and the heat rejected in a cycle is equal to the work done. I mean, there is no change in the internal energy because it's a cyclic process. So going by this, Q1 is the heat absorbed. So Q1 is the heat input to the engine, Q2 is heat rejected. So the net heat taken by the engine is Q1 minus Q2, which should be equal to the work done, because it's a cyclic, heat engine is a cyclic process, and so there's no change in the internal energy. So Q1 is equal to Q2 plus W. So what is Q2? Q2 is given as 0.4 and W is given as 0.65. Remember that kilowatt is also kilojoules per second. So this is basically 1.05, 65 and 40, 1.05 kilojoules per second. So now we come back to our original equation for reversible. We need to find out T1, which is the temperature of the source. So that is nothing but Q1 by Q2 into T2. So Q1 is basically 1.05 and Q2 is 0.4 into T2 is basically T2 is given as 300. So from this basically we get the, when we multiply this, so it's just, now you have to just use the calculator, and what you get is 300 into 1.05 by 0.4, so you get as 787.5. remember this is 787.5 Kelvin, and in Kelvin only it is asked. So it's a simple problem. You have to just understand what is valid for reversible heat engine. So always remember, keep this equation in the mind when you're dealing with reversible heat engine. So answer is 787.5. Thank you.